So we're still working with rational expressions. The next part is simplifying complex rational expressions. So that's when you have fractions inside of fractions, and they can be quite messy. So here I have an example written out, and what I want to look at is every single separate term in the numerator and denominator. And of each of those terms, I want to look at the denominators. So this one has a denominator of 1. It's understood, so we don't have to worry about that. Same with this x. You could put a 1 underneath it, but that's not really necessary. So what I really want to focus on are these other two where they have a denominator other than 1. So we have an x squared and an x. And what is the LCD of x squared and x? So that is x squared. So what I want to do is multiply each of these terms on the top and the bottom by that LCD of x squared. So I'm going to have to multiply it by the 1. I'm going to have to multiply it by the 1 over x squared. I have to multiply by the x and the 4 over x. So each term is getting the exact same thing because what I'm doing is multiplying by 1 to clear out these smaller fractions. So I'm not changing the value of anything. I'm just changing the way that it looks. So x squared times 1, that just gives me an x squared. The x squareds there are going to cancel, so that I just get a plus 1. Then down the bottom, x squared times x is x cubed. And this x will knock out one of those, so I'm just left with minus 4x. I have to check to see if this simplifies. I can't factor the top. X squared plus 1 isn't factorable. The bottom, you can take out an x, and we get x squared minus 4, which factors further to x times x minus 2 times x plus 2. But as you can see, there are no common factors that cancel out, so I can't do anything further with that. Do one more example. We have 1 over a plus 1 over b, and then 1 over ab plus 1 over b squared. So again, I want to look at all these smaller denominators for each term. I have a, I have a b, I have an ab, and a b squared. So my LCD, I know I have to have an a, and I need a b squared because I need the bigger power. So my LCD is ab squared. So every one of these terms are going to have to be multiplied by the ab squared. So here the a's cancel, and I'm just left with b squared times 1. Here this b knocks out one of these, so I'm left with ab. On the bottom, this a and this a cancel each other. B and b squared, I'm left with a b. And then this last one, the b squareds cancel, so I'm left with a. So I have b squared plus ab over b plus a. And again, I want to factor, so I can pull that b out. And then you can see those factors of b plus a cancel, so my final is just equal to b. And then the last part for rationals is we're going to go back to rationalizing with the radicals. So in the other section, we did rationalizing when there was just one term. If you have more than one term, you're going to use what's called the conjugate. And all the conjugate is changing the sign, SIGN sign, from positive to negative or negative to positive. So if I have 1 over 1 plus the square root of x, and I want to rationalize this, which just means I want to get that radical out of the denominator, I'm going to multiply the conjugate. So instead of 1 plus the square root of x, Because it's a plus here, it changes to a minus. The terms, other than that, stay exactly the same no matter what they are. All you're doing is switching. Because it's positive, it's a negative here. And the reason you're doing that is because you're creating the difference of two perfect squares. And we know when you have the difference of two perfect squares, the middle terms always cancel out. So I'm just going to do this multiplication out, which you don't have to do it all the time, but I'm going to do it out on the side so you can see why this works. So I'm just looking at the bottom here. So when I FOIL it, I get 1 times 1 is 1. 1 times negative square root of x is negative square root of x. Positive square root of x times 1 gives me positive square root of x. And square root of x times negative square root of x gives me negative of the square root of x squared. And we can see these two terms are going to cancel each other out. And we're squaring the last term, so we're end up getting just negative x. So this simplifies to 1 minus x. The shortcut is take this term, square it, minus this term squared. So you don't have to actually do all this FOILing out. So 1 minus x, and then multiply out the numerator, and that is rationalized. So I have 1 over square root of 7 minus the square root of 3. Because it's minus, the conjugate is square root of 7 plus square root of 3. So multiply the top, we just get square root of 7 plus square root of 3. The bottom, remember I said you're just squaring that, so that square root of 7 squared gives you 7, minus the square root of 3 squared, which is just 3. So we get square root of 7 plus square root of 3 over 4. And if you don't trust it, multiply it out. Square root of 7 times square root of 7 is 7. Then we get plus square root of 21 minus square root of 21. Those are gone. And then minus 3.